Okay, up to this point, we have added a negate, an unity operator, right? So you need to implement all the derived unity operator by yourself, and then arrange all these options into a combo box, right? Similarly, I mean, you just refer to the demo application that I give to you. So you need to do that by yourself, not just put a button here, all right? But I think I'd like to add another unity operator for you to see what happens. So I kind of use copy and paste it. So I intended to demo another unity operator. So that should be what? Should be concentration. Concentration. Okay, try to do concentration. Again, that is a unity operator. So you kind of extend the unity operator class family. Somehow it's almost similar to the fuzzy set we have done there. So as btn concentration. All right, so let's go back to our unity operator right here. Unity operator is fuzzy set unity operator, unity fuzzy set operator. Fine. Okay, within this C# file, we have two classes defined here, right? So it's okay because our class is very simple. I mean, you just override several functions. Next, you can implement some customer operator defined by the scholar and some expert. So you can implement. You can really use the parameters. But remember that if you use define a parameterized unity fuzzy set operator, you also need to generate the event, because if your parameter change, right, then the unity operator fuzzy set should subscribe your event. So remember that. Always remember that. Just like what we have done in the universe, right? If you look into your universe, because user might change the parameters, so we have defined an event there, right? So similarly, well, to make your class functionality complete, if you think that some other class laterally might need to know your parameter change, because that guy depend on you, right? So you need to provide such kind of event to that the other object can subscribe it. So once you, because other guys depend on you, if a certain value of you changed, then the other guy might have a chance that you can invoke his function to do the corresponding changing. Okay, so that's the idea. So later on we will go back. I mean, I'm not going to do that for you. If your unity operator for this unity for this operator, you do have implement another one, you need to well, probably add, similar to the universe, add some event here. So later on I will discuss a little bit about what is really an event constructed. So we will see that later. But here I like to add another unity operator. So I kind of start from public class. This time I try to implement a concentration fuzzy set operator, right? Again, inherit from unity fuzzy set operator, right? Okay, and this is the definition, the body of this definition. All right, so constructor, right? Constructor is okay because the base class does not have any particular constructor. So by default, there should be a default constructor created by the C# compiler for you. So you don't need to specify. But we like to name our name, right? That means in our constructor. So well, I add a constructor and type the secret word CTOR, right? Hit tab twice. We just need to prepare this skeleton for you. Okay, I will name my name. That is value. Okay, it's much more understand. Since concentration, for linguistic meaning model creator like to use this kind of fuzzy vocabulary to specify his condition. So it's much better. How about the calculator? All right, so we override it. Click on the blank space key, then IntelliSense will show up the available, or actually non-overwritten yet function, virtual function for you to override it. So again, override this calculator. Hit tab key. We just will prepare this skeleton for you. So how about concentration? Well, if you give me an x value, I simply return what? It's very simple. X times x, right? X squared. Look into this slide, you will see this the calculation of this unity operator. So you need to implement the rest of the unity operator you have seen in the textbooks, and especially some of them has been defined in the exercise. So you need to implement by that, implement them by yourself. Okay, so I have a concentration fuzzy set operator, right? So similarly, I subscribe this event. Right? So it's quite similar, right? So we needed to identify the fuzzy set. User needed to select one fuzzy set. Otherwise, this button will not be enabled. So you needed to do the for proof, or probably foolproof mechanism for the user not allow the button to be clicked. If user click on different kind of node, so you need to set some button disabled, right? Okay, so you need to do that by yourself. Okay, so let's get back here. So pretty much the code the same, because right now we kind of implement that by using two buttons. You are not going to do that. You need to prepare a combo box, right? Just prepare a button. So user select a kind of unity operator. Then user select a fuzzy set. So only when these two cases are met, then the button is able to generate a unity operated fuzzy set for you, right? So here I just want to show you the resulting fuzzy set only. Okay, so similarly pick up the fuzzy set, and then this time you see this is a very interesting statement. We kind of instantiate a derived class, right? An object of a derived class, but we kind of assign these references to operable. The operator is unity fuzzy set operator, so you don't need to specify that is a negate AFS operator, even though we know this button is dedicated for the negate operator, but you don't need to do that. That is the beauty of object-oriented technology, because all the object children can be regarded as object of the parent class. Remember that. Son, if you are a son or your father, a son is better, stronger than the father. So the object of son can always represent parent to participate in the activity that has been defined in parent, because you inherit it, but you have extra data, extra functionality. So the derived class is always superior to the parent class. But in parent class, usually we will define the genetic functionality. Probably some of them we will define that as a virtual function. So to let the derived class can override it. So that is the mechanism of so-called polymorphism. Okay, so polymorphism. All right. So here again, we will create a concentration fuzzy set operator. So right now all P is in fact an object or concentration fuzzy set operator, right? All right, so similarly, we will create a unary operator fuzzy set, right? Because we do invoke this constructor. But again, similarly, it is not necessary that you specify this variable, the unary operator fuzzy set. Actually, I still can declare that as a generic fuzzy set. Children class, parent class. The object of children class can always be, well, assigned to a parent references. But if you start from here, what you can see, the function or property is restricted to the generic fuzzy set. Fine, but up to this point, it's okay. I don't really care what specific fuzzy set it is, so it's okay because we kind of invoke this negate. No, not just negate. Let me change the name. So if you want to change the variable name, don't change it one by yourself because still you might miss something. So always let Visual Studio change the name for you. So here I will rename it negate fuzzy set. I should call it varied fuzzy set. Apply. So Visual Studio will change the name all of them for you. So similarly, I have a name, right? TN, tag. So the rest of them are should be the same. So actually, eventually, these two functions will be combined into a function. So you might have a switch statement or if else statement in top of it. You know, in order to make sure the selection, the operator selection, selected down by the user. So up to this point, we might see the value unary operator working fine. Show curve, yes, we like to show curve. Add series to chart, yes. Okay. So simply add another unary operator, right? So initially, again, these patterns are not enabled, right? So you need to do the for proof logical implementation. So create a universe, and then in particular, you need to populate the code in after select, because if you use a click on a guy, right? If it is on the universe, then this button will be activated. So use a special Gaussian, click a Gaussian, and after that, user might click the second label. Second label should be fuzzy set, right? So if the second label, the fuzzy set has been selected, this button will be enabled. Right. So this time I use concentration. Again, that is concentration, right? So user again, if user select this very Gaussian 1, right? Click on the concentration again. Very, very Gaussian, right? It's meaningful somehow. But later on, if you change the name, for example, if I change the Gaussian name, I might call it hot. Whereas you can see, something's still missing, right? This guy depends on this guy, but the name of this very Gaussian does not change its name. It has better maybe change into very hot, very, very hot, right? So again, there is still somehow a pitfall there. The naming scheme is not sustained, so you can try to fix that out. But the problem come here is that if I kind of change the parameter, not just the name, change the parameter of hot. For example, if I move the center, click on hot, mean, right? 9.5. So this time I change the mean into 5. Sigmoid function. No, it's a Gaussian function. The peak is right here. The center is right here. It's interesting. Why I do not have a standard deviation? Oh, okay. Probably I will change it. So since the value Gaussian depend on Gaussian, right? But this time Gaussian change its parameters. This line does not change its position, right? It does not seem to be right. Why? Because the problem is that the unary operator fuzzy set depend on this fuzzy set, right? But this fuzzy set has changed its parameter. But there is no way I can know that because your fuzzy set does not provide an event for the derived fuzzy set, even though both of them are in the class family. But the genetic fuzzy set does not provide a parameter change event for another derived class to subscribe it. So that is the problem up to this point. Okay, so let us take a closer look at the event, what we have done in the universe, and I'd like to spend a little more time to discuss about the event. What is the event? Last time I tell you guys that an event is closely related to a terminology called delegate. Delegate is a data type defined in C# programming language. Delegate, D-E-L-E-G-A-T-E. So if you want to define an event, you should always specify the event is public, just similar to the property. But using a keyword event, and then name the event name. So as you can see, our universe has a parameter change event specified. What is this? This actually is the type, and this type must be the delegate type. So event handler is a delegate provided by Daniel framework, and it is very simple. Actually, this delegate has been used in a lot of control. You see, once we subscribe, for example, if I subscribe a button, if I subscribe the click event of a button, as you can see, this is the function signature, right? Function signature including the parameter. There are two parameters specified within this function. The first one, the data type of one should be object. The second one is event arguments. So if you define your event, just like we have done in our universe, right? Our universe is saying that, okay, I have parameter change event, and the delegate is the event handler. So where did we subscribe that? We have subscribed the parameter change event of the universe in the genetic fuzzy set, right? So let us take a look at it. Do I have? No. Okay, so let's go back to the genetic fuzzy set. So when we construct genetic fuzzy set constructor right here, when we construct an object of genetic fuzzy set, see, we subscribe event by using this operator plus equal. Plus equal, the meaning of plus equal is that this guy has an the content of this guy does not change, but just add another one to its content. So this one is a function, right? So this function is prepared by Visual Studio, right? So we just let the tab key have us. So when we hit the tab key, Visual Studio knowing that this kind of event has a delegate specified as the event handler. So an event handler is delegate. So we just will prepare this kind of function skeleton for us. This function should take two arguments. The first one is sender, the other is event argument. So this event, so in this case, this event has been using the default delegate for general event. All right, so if I don't want to use it, if I don't want to use the default delegate, then you need to define your own delegate. So this time, let us probably just practice a little bit about the delegate, okay? So then let me go back to our, go to our, right here, just generic fuzzy set, right? So generic fuzzy set, when an instance is instantiated, we subscribe event from what? From the universe, right? But right now, if the parameter has been changed in the generic fuzzy set, we needed to provide an event to let other guys subscribe it. So It's about the time we add an event to the generic fuzzy set. So we like to add that in the generic fuzzy set, not in the Gaussian, not in the derived class. So we put it here. So okay, so let us go back to our properties, and this time I kind of add the event. All right, so since a fuzzy set has a bunch of parameters, right? So similarly, we might call our event parameter change, right? It's meaningful. So declare as public event, and then we need a delegate somehow. And then we'll call it parameter. Excuse me. Okay, so we need to define a delegate for your usage. So suppose this time, well, because when this event is triggered by a fuzzy set, right? So fuzzy set might change name, might change some parameter, then this event has been changed. So we will fire this event, right? So what is the event? Event is actually a correction. Actually, it's a correction of function pointer. If you are familiar with the C programming language, in C programming we have a data type called function pointer. So function pointer is a variable which can store the address of a function. So later on you can access that function via this address. So it's called function pointer. But in C#, delegate is more than just one function pointer. Actually, it's a correction of function pointer. So a delegate try to collect more than one function pointer. So when this event happened, it will execute the function provided by the user. If you subscribe this event, then you will need to prepare a function, right? And then pass your function address or function reference to this delegate. So that is a delegate. So we need to put a delegate right here. All right, so it's about the time we practice a little bit about defining our own delegate. So outside the class, delegate is a type, is a type of C# programming. So we kind of start from design a PUBIC delegate, use the keyword just like a class. So we might call it what? Might call it, well, maybe this is fuzzy set parameter handler. So this is delegate's name, right? But you want to define, when you define a delegate, not just the name, you need to specify the parameter, because eventually a delegate will invoke a bunch of function call, right? So it is almost like defining a function, but actually we are defining the signature of the function. So suppose I don't want to provide any argument, right? And I will not return anything. So that's it. I have defined customer delegate. The name is called FS fuzzy set parameter handler. Okay. And this function, as you can see, it's almost like the function template. Somehow you can think in that way. So that means this is delegate. It will collect the function pointer. Those function does not have any argument passing, and the function does not return anything. Okay, this kind of function can be added to this delegate. Okay, so right now we have a delegate, right? We have delegate. So the delegate, the feature of delegates look like this one. So a function does not need to have any parameter passing, and the function does not need to return anything. So this kind of function can be collected by this delegate. All right, so we have a delegate ready, right? Okay, so if I use my personal delegate special right here, so our generic fuzzy set right now, we have published an event, right? Parameter change event. And the delegates look like this one. So once in your generic fuzzy set, right now you have parameter change event, right? So all the derived class within this class family needed to take care about this parameter change event, right? So in the property, so probably the name change, right? The name change, if you think about even the name has been changed, and then the name is one of my parameters, so you need to fire, you will fire it. Okay, fine. So in this case, well, maybe that is not a good idea. Okay, so maybe up to this point, we are not going to add the event trigger right here. So probably let me step into where? Into a parameter Gaussian fuzzy set. So Gaussian fuzzy is here, right? So when Gaussian fuzzy set provide a property to let the user change their mean, right? Mean has been changed properly. Standard deviation, probably double 2. Okay, so these are the public property. So since the property has been changed, right? Okay. I don't know, this guy, it seems that it copied from last year's version. All right, should I do that? Do we have a parameter change function? Where is it? I don't think we have this one, parameter changed. Oh, okay, yeah, this one is done by us, right? Okay, because if the parameter change, right? Yeah, it's parameter change. So we have function right here, right? Parameter changes. So we need to, because parameter has been changed, right? So within this function, we kind of, if the series is non-noun, that means we like to show our series on the figure. So we need to populate our MF point. So good. This function has been declared in the genetic class, right? In the genetic class. So the derived class can call it, no problem. So we will call it right here, right? And it is about the time we fire this event, because right now we have parameter change event, right? Parameter change. So within here, we kind of, you can say it's trigger, T-R-I-G-G, a trigger, P-I. Okay, take a look at the universe classes. How can we do that? Parameter change, right? So if user change the name, not name, change the max value, right? So we kind of check this event. If it is non-noun, meaning what? Meaning the collection do have a function pointer subscribed by the other object. So we just use this delegate to invoke the function. And since the function delegate take 2 arguments, right? Take an object, the other should be the event argument, right? So we supply these 2 data for the event trigger. Okay, so that is the way we we trigger this event. So back to our genetic fuzzy set. So about the time, since right now we have event general, so event, so we trigger this event. So it's explained if PAI parameter change. Not equal none. So we fire this event. So how can you fire event? Actually, a delegate actually is a, you can think about that is a function representer. Correct. This delegate actually is a collection of function points, so we call it. But this time, because our delegate does not need to does not need any parameter, right? So we do not have any parameter passed to it. So this is the way we define our parameter change, and we use our own delegate. Our delegate stated that the function does not have any argument passing, return void. So when we fire it, we just use this event indirectly invoke all the function that has their reference stored in this delegate. Okay, this parameter change. Maybe later on we will see what happened right here. So let me set a breakpoint. So the whole idea is that we did not use the default event handler delegate. We use a custom delegate designed by us. So we do not pass any argument to it. So let us go back to the let us go back to our unary operator for this set. Our unary operator for this set. So when we create an object unit operator, we need an operator, right? OP. Also, we need a fuzzy set. So within this definition, a unary operator fuzzy is about to be created. But since this object will depend on this fuzzy set and depend on this unary operator, right? So far, the operator does not have any parameter, right? But fuzzy set do have parameters. So if the this target fuzzy set has parameter change, we need to change our series, right, accordingly, right? So we need to subscribe the event changing, the parameter changing event of the fuzzy set fs. All right. So during our constructor, we kind of add fs. Right now, the target fuzzy set is fs. All right. So how can we subscribe it? See, similarly, fs dot. Right now, even though we know that it's Gaussian, it does not matter whether it is Gaussian or it's triangular fuzzy set. They have inherited from generic fuzzy set, right? From generic fuzzy set, and generic fuzzy set do have a parameter change event. Right now, we just added. So we subscribe this event, parameter change event. If you want to subscribe it, you are not going to use assignment. No way, you cannot do that. You can always the only way you can add a subscription is you need to use plus equal. So once you type plus equal, internet prompt for that. Oh, okay. You please press the tab key. The Visual Studio will prepare a function skeleton for you. So I hit the tab key. You see, in this time, Visual Studio know that this event, the delegate associated with this event, the function does not have any argument passing. The function will return void. So this is prepared by the Visual Studio. But it is because it is defined in the delegate of this function. Excuse me, the delegate of this event. So our parameter change event kind of link with the the delegate link is customer delegate. And that the delegate is saying that, well, you just provide a function, does not have any argument passing and return void. So that's it. That is the current design, because we have in generic fuzzy set we have our own delegate defined. This is defined. This delegate is defined by us. So right now, our parameter change event uses this delegate. This delegate saying that, well, the function associated with the event does not have any argument passing or return void. So as you can see, when we subscribe this event in the unary operator fuzzy set, when we hit the tab key, the Visual Studio prepare the function skeleton for us, which is consistent with your delegate declaration. All right, so okay, so because the parent, the target fuzzy set do have parameter change, right? So we need to change our series, right? So within here, how can you change that? Well, we simply call, as you can see, if go back to the when we go back to the Gaussian fuzzy set, you see, when Gaussian fuzzy set, the parameter has been changed by the user, right? If your parameter change, you call inherit function parameter change. Parameter change is defined in generic file set, right? So we have parameter change, right? So when parameter change, what you need to do is that you repopulate your membership function point, right? And then fire out the parameter change event. So it's kind of, it's chain reaction. You can trace that. It's very interesting. Via this kind of event trigger mechanism, we can let this, you see, we have very, very hot file set general, right? That unary operator file set depend on another unary operator file set, right? And that unary operator file set depend on Gaussian file set. So it will be triggered in a chain reaction style. So it will automatically update their shape too. Okay, so up to this point it's okay. So what we have done is actually in the generic file set, we kind of published an event, right? So we say that okay, from now on, our generic file set will have a parameter, right? Parameter change specified, because we do have parameter, which is similar to the universe, right? Universe has a parameter. So we do take care about this event. So when our parameter change, this function will be called, right? So within this function, we trigger this parameter change event. If anybody subscribe this event, that body will be informed. That body, the function provided by that body will be invoked. All right. So let us just take a look what will happen. So we have a universe defined, right? If I add a Gaussian file set, add it, and if I change the parameter in U1, right? So U1, so last time we know that if the user changes the minimum into -5, click on some other place, well, it is updated, start from minus point. So this point has been updated. And this time, if I click on Gaussian file set, then I click on the concentration operator. So it's very Gaussian one, right? So if I select this guy, similar, right? I add another concentrations. So it's very, very, extremely very, right? All right, so back to the original Gaussian file set. If a user changes the parameter from 1 into probably into 5, change to 5. When user click other place, try to make this setter happen. Okay, so come back to the generic file set. It's about the time we populate a new point and move your cursor to the parameter change event. It is not none because the derived, the unary operator file set subscribe this event. So clear the breakpoint. All right, so fs parameter change. So we did not do anything, right? Our unary operator file set right now this function, because we subscribe this event. So fs parameter change, we did not do anything, right? Okay, so this function has been called, right? But we need to implement our logic right here, right? So if you are a unary operator file set, okay, you subscribe it. You subscribe the parameter change event from your target file set. So right now the target file set calls your function. So what should we do in our unary operator file set? Well, since I depend on other guys, right? I depend on this target file set, and the parameter of this target file set have been changed. Some other guy might depend on me, right? So it's about the time I will call my parameter change function, parameter changed. It's a function, parameter change function, right? Parameter change function is inherited from the parent. So that's it. So it's kind of chain reaction. One call the other one, one call the other one. So that's it. So let's see what will happen. Again, U1 Gaussian fuzzy set. Okay. Select one, select concentration. So we have very Gaussian came out. Another very Gaussian came out, right? So if I change the parameter of Gaussian, change the center from 4 maybe to 2, activate it. All of them, you see, all of them, the 0 point will be updated too. So that is the beauty of the event trigger and function invocation. I mean, the customer provided function will be called. So that will be trigger. This kind of event will be trigger. So it's working right now. All right. So if I change the Gaussian again back to 8. All right. So probably you start from this point, right? From very Gaussian one, you will get a negate on this one, on this very Gaussian one. So all of them, all of these 3 fuzzy set actually depend on this guy, right? So again, if I change the parameters of the primary fuzzy set into 3, not just the value varied, also the inverse negate one has been updated. All right, so that's the beauty of the event definition. So we needed to do this kind of implementation, right? Okay, so up to this point, you see, within this panel we have anchor. This is important one, but the rest of them just anchor left and right, extreme left and top. So you need to arrange this user control a little bit more. I mean, well, arrange the position and the size somehow, make it look better. So, all right, so that will be the event we needed to add to our fuzzy set. So it is pretty much, I mean, but for the binary operator fuzzy set, right? Because right now what we have done is unary operator fuzzy set, so it's very simple. User select one fuzzy set, then apply a unary operator, right? But how about the binary operator? In the textbook, we have a lot of binary operator, right? Union, intersection, right? And again, we still have another unary operator. So you need to implement that. For example, cut. Well, cut is again a unary operator for this set. So if you want to, well, for example, if this guy, let me see. What I do is I may call it a general button. Create a binary fuzzy set. So I'm not going to instruct anything about binary operator fuzzy set. You need to do it by yourself. Well, what is the difference between unary and operator? Well, we just take another operand, another fuzzy set as the second operand. So your binary operator fuzzy set will depend on what? Depend on a binary operator. The first fuzzy set, the second fuzzy set. So you need to subscribe event, subscribe parameter change event of the first fuzzy set and the second fuzzy set. And if your binary operator fuzzy set do have parameter change event, you also need to subscribe that in order to change your parameter. I mean, it's consistent with the parameter change of the original operator or the target fuzzy set, right? All right, so if this is button create a binary fuzzy set, we need to let the user specify the target fuzzy set, right? So since the target set, since the tribute actually is single selection, so we needed to provide some. We needed to provide a. Well, let me probably do it here. So maybe this is binary operator. So it will look into, well, a selection. So the easiest way probably should be the label. So label, this is label, and probably initially, well, select both of them, change the property together. So the property should be auto size, right? Auto size, set the property to false, so we can kind of enlarge it. So probably we needed to, well, so initially in label 1, okay, label fuzzy set 1, this is a label. Fuzzy set 2, lab fs2, lab fs1. Okay, so in the text field, in the face text, you must, well, select first fuzzy set. Select second fuzzy set. Be specifically select for this first fuzzy set and click. So probably to that. Select second fuzzy set Alright, so what is the scenario? So suppose user select a fuzzy set from the tree view, so we can pick up the fuzzy set from the tag, right? So we know the tag. And then if user click on this this label, so we will make a copy of that fuzzy set and store. You see, take a look at the label. Label do have another tag, right? So we have a tag. We simply copy the fuzzy set and put in here. And then we will print out the fuzzy set's name here. So when user click on button, try to generate a binary operator fuzzy set, then we will have this both. We will pick up the first fuzzy set from the tag of this label. So that is the idea we'd like to have. All right. So it's label 1. So subscribe is event, right? Double click on it. So how can we get the fuzzy set? We needed to check. Okay, we needed to check TRV fuzzy set model, right? Selected node. So we don't know the selected node, right? And we always know that we are tag to hide something, some object, right? So back to our tree view. The first label is universe. We actually store universe. The second label we store the fuzzy set, right? So how can you check about that? Okay, so let us go back to the main phone. So click event. So tag, well, it's about the time we introduce is. Is an operator or C# programming language is. So the left is object. Object is type. So for example, class. So this is an expression. The result should be true and false, right? So we will check if the tag is generic fuzzy set. So remember that probably you guys are not familiar with this operator. This operator tries to evaluate a condition. If the left-hand side object is really belong to the right-hand side type, then it will return true. Otherwise, it will return false. Okay. If this tag is in fact a generic fuzzy set, then we will store it. So we will store it. So label fs1 tag. We will copy it from this button here, and then change the face text to what? So we always well, actually, if you know this guy is actually a generic fuzzy set, right? So we will cast it. So usually you can use okay, I will use this guy, the data type. Well, we use the data type right here. If you put a data type and then wrap it up with a pair of parentheses, which means that it's a caster. We kind of cast on what? Cast on this tag. So once you cast it, then the result will be the generic fuzzy set. So what we have done here is that we kind of cast the tag. Remember that tag is an object type, right? So we cast it, but we know that right now, since it's the generic fuzzy set, so we can cast that as a generic fuzzy set, and then so the result turned out to be a fuzzy set. So we access its name. Okay, this is one way to assign the text. So either way, we cast it, or you can use S. S is another operator of C# programming language. Try to convert an object as a type. So it is the functionality is equivalent to the casting, but the result is a little bit different. If the cast fail, then you will receive an exception. But if you use S, try to cast it, then if it is not convertible, then it will return none. Okay. So either way you use casting. So I'm putting right here. This is casting. Or another way you use S, the operator S. Try to turn. Okay. So take S. This type of generic set. Both of them are okay. I'm using either way you can do that. So only the tag is a generic is a fuzzy set. Then we pop out the we kind of store that tag into the label fuzzy set. So let me set a breakpoint. So these two labels are basically used for your binary operated fuzzy set generation. Okay, so U1 we have a Gaussian fuzzy set specified. Oops. Gaussian fuzzy set, and probably use my special another triangular fuzzy set. So both of them are ready, right? So if I select a tree node, right? So if I select U1, if a user click on this label, what will happen? All right. So the tag, you see, move your cursor into the current selection. Yeah, we do have a current selection. The text is U1. How about the tag? You see, tag in fact is a universe. Remember that in our universe we do have override the two string function, right? So we put a universe and then put a name there, right? So okay, so right now the tag actually is a universe. We know that. So is a object of universe is a generic fuzzy set? No. So the is operation will return false. Oh, excuse me. So if I hit F10 key, oh, okay, I'm sorry, it's running right now. Okay, so let me try it again. So user create a universe, and then based on this universe, user add a Gaussian fuzzy set. So user try to make a different kind of selection. So this selection is a universe, right? So behind the tag is actually is a universe. And then if user try to click on this this label, so we came to here. And how about the tag? Tag is universe. So is tag so definitely it is universe is not a generic file set, right? So if I hit F10 key, so we came to this point, it is not executed, right? So fine. But this time, if I select a Gaussian file set and click on this label again, so how about the tag? Tag is you see, we did not specify, we did not override the toString function. So if you did not provide a if you did not override the toString function, we just still will show up the data type, So this is a namespace. The data type is a Gaussian file set. But we know definitely this is object of Gaussian file set, right? The Gaussian file set is a derived class, right? But actually, it is actually again, it can always be treated as an object of the parent class. So its operation is true in this case. It's true. All right. So since it's true, so we copy the tag to the labels, and then we update it. So we kind of cast. We know the tag definitely is Gaussian file set, right? So if we cast the Gaussian file set object into the parent class, then definitely it's okay. So we cast that, it's okay. So we treated that as a generic file set when we access its name. So no problem. So right now text is what? Gaussian 1. All right. So similarly, either way you cast it, or otherwise I use as convert this object into this data type, and then try access name. So both of them are the same. Actually, you don't need to specify both. You can either way choose on one expression that will do. So Gaussian 1 is ready, right? And if user selected another file set, for create another file set. So select E1, add another file set. So right now we have triangular file set, right? So suppose the user click on a triangular file set and then click on this label. Well, I did not subscribe this event, so then I subscribe it. So back to your phone, main phone right here. So this label again, subscribe to click event, right? So almost the same, right? But the label is different. So only difference is label 2, label FS2, tag, text. Okay, so already know tag is what the same, blah blah blah. Okay, but before we debug it, let us quickly add an overridden toString function. So we came to the Gaussian fuzzy set. It's a derived class, right, from the generic class. So up to this point, I kind of override function populate constructor. Okay, so now never mind, I can put my function here. Again, I use override secret word or override secret word. Hit tab key, and then type a blank space. So we can override toString, override the two. These functions are actually inherit from object. So in override toString, so how can what kind of string will return? Okay, I'll call it, well, it's a Gaussian, right? Oh, excuse me, it's generic. Okay, I'm not going to do it right here. Sorry about this override. Actually, we like to do it in the generic file set. So we have property, right? We have property. So this property standard deviation. Standard deviation parameter. It's very interesting. Why this does not pop up? Public double. Okay. All right. Constructor override function. So again, override. Let me override toString right here. toString. So in this time, in the Gaussian file set, I do override it. So I will call it GAU as Gaussian file set colon, and I use formatted, return a formatted string. I put my name here, Gaussian file set name. So it's toString. So I just override the toString on the Gaussian file set. I did not do it in the triangular file set. Okay, triangular file set I did not do it. So did not override it. So it is better that you override the toString on all the derived file set. Create universe. Gaussian file set created, right? Again, now I create another triangular file set. Edit. So if I click on the Gaussian file set and try to select it right here. So move cursor, come here. You see, once you click on the tick, you know it's Gaussian file set. Oh, interesting. Still, it's just Gaussian file set. Interesting. So Gaussian file set. Then Gaussian 1. And if I click on the triangular one, create this guy, triangular one. Okay, I did not set a breakpoint there. So that means two Gaussian file set has been selected. So you can apply this button, create a particular binary operator file set. For example, union of these two Gaussian file set or intersection of these two Gaussian file set. But you need to pay attention to that. These two Gaussian file sets should be defined on the same universe. You should avoid false selections. For example, if I generate another universe, U2, right? And within the U2, I do have another sigmoidal function defined. If I select this guy, click on the label one, right? So right now it's left right defined on the universe U2. But how about I select triangle one, click on the label 2. Let me change it. Gaussian 1, change it into Gaussian 1. So can we perform a binary operation on these two file set? No way. Oops, excuse me. Select this one, click on this one. So if I click on this button, you should avoid this kind of creation of a binary operator file set, right? These two Gaussian file sets are defined on different universes. There should be no any binary operator file set generated from these two file sets. Okay, so you need to do the checking for the selection. So it is better that user will not going to select it successfully here. So if you can probably spend a little bit more time on the fault proof mechanisms there. For example, if you can do the checking right here within this function. So not just make sure it is Gaussian file, you need to check the other guy. So in label F1S click, you need to check if the label file set 2 has been assigned with file set. You need to check whether this file set and that file set which has been selected are on the same universe. You think about that. I mean, how can you do that? So you need to do that so-called foolproof mechanism. I mean, in your user interface, not that the user define two select two file set defined on different universe. So you are not going to let that happen. And then once user click on this button, a legal binary operator file set will be generated. All right, so later on you need to do the population UI population by yourself. So basically, what you need to know to add is a combo box, right? A combo box, right? This combo box will list all available binary operator for you. So user select a binary operator. So let me probably add a label right here to guide your user. The face text should be, well, select and binary operator. So this is a list combo box, right? So that should be CBX binary operator. Which is similar to select file set, right? So similarly, in your user interface should be what? Select a unary operator. This one should be combo box CBX unary operators. So forget about negate, forget about concentration. You should have a button create a binary operator for this array. So this button should be btn create unary operated fuzzy set. So in the face text, so you put this text create unary operated fuzzy set. Anyway, just you need this kind of user interface to let the user quick, right? So make sure, I mean, a lot of conditions needed to be a foolproof mechanism should be done in where? In this event after select. So after select, you see the mechanism I will show you a little bit. You need to make that complete, okay? So when a selection is selected, right? So how can you identify whether this selection is on the universe or on the fuzzy set? Well, it's very simple. See, we have selected objects in node. Well, since right now the selected node is stored in this argument, right? So we have e node selected. So we can check that whether the tag is a triangle. So we know that user have selected it. Or otherwise you can use a property called label. So if label is 0, that means user has selected the zeros, the first label. So if label up to this point, if the selected node the label is exactly equals 0, meaning what? Universe is selected, right? Else if equal 1, that is the current situation. Later on, I mean, if we step into the assignment file, we will add another category called input universe, output universe, right? So in that case, you should have 3 labels specified there. Okay, so but up to this point, we just have 2 labels, label 0. So the universe selected, and if the label is 1, that means fuzzy set. So if the label is 0, can you allow the user to add you will allow the user to add what? To add unary operator fuzzy set, right? So this guy btn create unary will be enabled, right? And also this one will be enabled, right? So btn add Gaussian. Well, the name is not okay, right? What is button name? Okay, btn add file is set. All right, so btn add file is set. btn create unity operator. btn create file set. Okay, so simple. So let's go back to this this event. So btn add the file set enable equal btn create unity operator file set. So you need to specify your own name, right? btn create binary operator create unity btn. Where is the binary operator file set? Let me see. Okay, button 2. I'm sorry about that. So let me change it. btn create binary operated file set. Okay, make sure it's clear. So go back to this click event. To change the logic, btn create binary operator file set that enable true. Right? Not exactly right. So we need to unity operator file set will be excuse that, right? They're different, right? So if we use a click on a universe, we will let the unit operator file set turn into false. All right? But when user click on a file set, then we will enable the unit operator file set true. While the rest of them are false, right? We are not going to add a file set on the file set. So but initially you should call it first, right? Call it. So probably should be none. Let me see. So initially nothing is generated. So initially both 3 buttons should be disabled, right? Just this button. So okay, let us go back to the initial condition. So initially this button has been set to disabled, enabled, false. Okay, unable to create any file set. So user create a universe first. Then if you use a click on a universe, so right now we can add a primary file set. And this one is not going to happen because we needed to make sure both of them has been selected, right? Okay, so this guy we needed to change our logic a little bit. So we're not going to the selection. We're not going to activate the enability of this button. No, we are not going to enable it. So it's a responsibility of what? Of the label. So just think about the enability. I mean, it's in different kind of situation to make the foolproof mechanism valid. Okay, add a universe, right? Add a universe. So now we can add a primary file set right here, Gaussian, then triangular, right? All right. So if user click on the second label, label 1 is the label 1, right? So we let the user create a unity operator file set, but again, not this one, right? It is not complete. It should depend on the selection. After all the selection, then we will enable this button. So it is not our responsibility about this guy. No. So in the tree node selection, we simply update these 2 buttons, the enability of these 2 buttons. Universe, click on this one, add a triangular, add a Gaussian, right? If a user, okay, add another property. So click on this guy, we are able to add, oops, excuse me, right here. Okay, if a user click on the label 1, that means fuzzy set, right? So it's about the time we can select what we can select this guy, so we can add a unity operator button. But right now we kind of move the button right here. So select Gaussian, add a negate. I did not see it. Gaussian, right? Negate. Oh yes, it is general right here. Negate Gaussian. Oh, okay, previous is negate triangular. And all right, so it's a unity operator for the if a user click on the universe again, so this button is disabled. And user change the parameter, for example, peak into 6. You can see the negate 6. The negate 1 will be changed. Oh, okay, no, not the case, right? Yeah, that is the reason. You see, in Gaussian function, we do call parameter change function, right? So you need to check the primary fuzzy set you have implemented right here, Gaussian fuzzy set, right? So parameter has been changed within here. It's Gaussian, right? In Gaussian, if our mean change, we will call parameter change, right? If the standard deviation Gaussian, if the standard deviation change, we will call parameter change, right? So similarly, in your triangular fuzzy set, when user changes the parameter property right here, if user changes the parameter 0, okay, parameter change should be okay. Why it does not happen? Okay, let me focus on the triangular fuzzy set a little bit. In this case, so universe, we add a triangular fuzzy set. We change the parameter peak from, okay, let me add a concentration. Okay, click on this guy, concentration, right? So we have concentration. If I change the peak value from 5 to 8, activated. Okay, yeah, it is updated too. So how about negate, right? Negate. Triangular negate. If I again change the parameter of left, no, peak, back to the 4. Yeah, okay. Yeah, because we have this kind of parameter change event fired mechanism, so it is working right now. So, all right. So this instruction, actually, what we have done is that we add an event to generic fuzzy set, right? We add the event to generic fuzzy. We call it parameter change event, but using our own delegate, So later on, if I have time, I will show you the delegate, the usage. But right now, since we kind of define our parameter, the function invocation does not need to provide any parameters, so we define it. This delegate will store function pointer whose function does not have any parameter specified and return nothing. Okay, that is the function targeted for our event trigger. So if our event trigger, if a user subscribe this event, we will call that function. That function will not have any parameter passing, and will not return anything. So this delegate is defined by us. So during our event change, during our parameter change, we fire it. During our event change, parameter change, we fire that event. So if a user subscribe that event, user's function will be called. Okay, I think so fun, so good. So the rest should be your job. You need to complete the layout design somehow to make it consistent. And you need to create what? You need to create similar to unity operator, right? This is unity operator. So what you need to add by yourself is that, well, you can start from here. Take a look at the unity operator. We might call it binary fuzzy set OPER, right? Operator. So think about the data, and then later on you might implement what? A bunch of derived class, public class, maybe called union operator, fuzzy set operator. Union inherit from binary operator, right? And not just union. How about intersection? Oh, okay, sure. Class is intersection fuzzy set operator. Inherit from binary operator. Okay, the differences between unity and the binary operator is the character value. So in the binary fuzzy set operator, we will have a virtual function declare, return a double. But since it's a binary operator, right? So my calculation take two arguments. Excuse me, calculate value. So I prefer using the similar name, but I will have double x and double y. So since we don't have any object instantiated from the genetic binary operator, so I put this function there, no implementation. So definitely your unity fuzzy set operator will inherit, right? You should override it. So type the override keyword, type a blank space, space key, character. So you do the union, right? So right now you have two values, which is similar to the T norm, S norm, right? You have two values. So what value will you return? Union, right? The largest one, right? X smaller than y. If y is smaller than y, then we return y, right? Otherwise you return x. So it's very simple. I mean, the structure-wise is simple. So you need to implement. You need to implement the others binary operators in this similar way. Take a look at the textbook. Some scholar and expert provide a binary operator do have parameters. So similarly, you might have parameters specified here, and you have a name specified here. So that's your job. So you need to do that by yourself. And how about the operator fuzzy set? This is the unity operator fuzzy set, right? Inherit from generic fuzzy set. Well, similarly, you need to define public class binary operator fuzzy set. It's a fuzzy set. Again, it's a fuzzy set. Inherit from generic fuzzy set too. Instead, you should define your own constructor. Right now, you are not just need one fuzzy set. You will need a fuzzy set 1 and fuzzy set 2. All right. So carry on the design by yourself from this point. Okay. So when everything is complete, then you can go back to your file. So you see, right now our unity operator fuzzy set have a lot of class, right? So it's okay. Unity F fuzzy set operator. So come here, wait a little bit, or properly click on it. Yeah, when this driver came out, that Visual Studio help you move this part of code into another file. So move type to binary fuzzy set operator CS. So the Visual Studio prepare this C# file for you. So Visual Studio will move this part of code to a new class. So right now you have binary operator fuzzy set operator. Okay. So, but during the development, probably you like to compare the unity operator fuzzy set and the binary fuzzy set. So initially you can put these two classes on the same file. It's okay. But later on, please move your binary operator project into another file. Okay. All right. So it's about the rest instruction that I'd like to let you know. So you need to start this assignment as soon as possible, because a bunch of implementation needed to be done for you, especially for the binary operator parts. So you need to do that by yourself. Okay, that's it.